In the world of product development, software security is becoming a major concern due to increasing cyber attacks and data breaches. Traditional software architectures are often vulnerable to these threats, and hardware limitations can impede performance. Development teams need more secure, reliable, and efficient solutions to build software products. And that's where the combination of seL4 and the AMD Xilinx Versal platform come in. In this interview, we'll hear from Zach Clark, an embedded engineer at Dornaworks, who has firsthand experience running seL4 on the Versal platform. Tell me about how you ported the seL4 microkernel to the Versal platform.
It was pretty similar to the Zinc MB socks. They're, like I said, a very similar platform. I'd say that the main difference that presented itself was that there is a Gig v3 on the Versal platform, whereas the MP sock has an older version of the Gig. So we actually were not emulating that newer version of the interrupt controller. And so that was probably the biggest challenge that we came across, was needing to add emulation of the newer version of the Gig rather than just being able to use the Gig V2 that the MP sock has.
What are the benefits of running seL4 on the Versal platform?
Before this, we would just use the Zinc MP, which is the top of the line before Versal. So the Versal is just like the evolution of that, you might say. It's newer one that came after the Zinc MP. And so since it was something that we've used with, like you said, the FPGA group, it was something that we wanted to see if we could get involved with seL4 as well, just to be able to say that we've used the most recent chips, that we're up to date with what Xilinx has available. And there's also they have the AI engines and stuff available on it, but would definitely be something interesting at some point to work with.
What are the key features of this combination of seL4 and the Versal hardware?
Like I said, it's fairly similar to the MP sock, the Zinc MP. So in that sense, it's similar from a security point from that to that. I'd say that the AI things are probably the most significant change here. So with other platforms, you might not have specific AI engines available to you that you would on Versal with seL4, you could share that securely between different VMs running on your uh, SoC. Whereas it's might be a little bit more difficult to have specific PL devices. You can share them securely, but there's not necessarily something specific for AI on other platforms.
What lessons did you learn by porting seL4 to the Versal hardware platform?
I mentioned the Gig earlier. That was definitely the thing that I learned the most probably about from the porting effort, because I had not really dived into the emulation of the Gig that we do at all before this. So then to go from never having worked with the virtual Gig other than just using it to now being like, oh, I have to emulate a new version of the Gig was definitely a new experience, and had to learn some things about the Gig in order to be able to emulate that. So I'd say the Gig was probably where I had the most learning experience from this project.